dia a todos. Vamos começar, que hoje tenho muita coisa para falar. E então, começamos primeiro por aqui. Deixa-me comprimir isto. Solutions, parte 8. Isso. Ok, finalmente chegou a altura do ROS. Portanto, nesta aula nós vamos mesmo falar de ROS, finalmente, aula 8. E a primeira coisa sobre a qual eu queria falar era sobre porquê ROS, ok? Portanto, eu vou-vos contar uma história de um projeto que decorreu aqui durante muitos anos, desde 2003, 2002, aqui no Departamento de Engenharia Mecânica, e ao fim e ao cabo da forma como o software foi evoluindo e a conclusão a que chegamos, nós, em conjunto com muitas outras pessoas pelo mundo fora, de que realmente o ROS era uma ferramenta muito útil para programar sistemas robóticos. Portanto, a ideia era, em 2002, participar num projeto de... Deixa-me pegar aqui. Pode ser aqui, talvez. Olha, se talvez possa pôr isto. Isso. Portanto, a ideia era participar num projeto de condução autónoma, em que o que se queria era desenvolver um sistema, um carro, um veículo em escala pequena, que fosse capaz de pegar uma pista, ok? Portanto, isto, estamos a falar de 2004, no pavilhão Rosa Mota, e na altura nós fizemos um carro, isto foi um projeto de fim de curso, vejam lá, há quanto tempo foi, fizemos um carro equipado com câmaras, portanto isto é uma trend, portanto para um carro poder conduzir sozinho tem que ter câmaras para ver a estrada, tem que fazer processamento de imagem para perceber o que está a ver nas câmaras, e depois, claro, tem que ter um cérebro, neste caso tinha um portátil em cima e cá dentro tinha um computador, uma motherboard. Pronto, e este era digamos assim, a competição. Nós participamos na altura e depois gostamos da coisa e continuamos a participar ao longo de muitos anos. Aqui no ano seguinte, em 2005, este vídeo é interessante porque mostra-vos ali a imagem de uma câmara que está colocada a bordo do robô para se perceber que isto não é nada fácil para o robô decidir. Portanto, a escala é mais pequena, mas uma velocidade mais pequena, uma escala mais reduzida, torna o problema mais complicado também. É como se fôssemos num carro normal mais depressa. Okay? Este vídeo ali faz-me lembrar a Fórmula 1. Okay? Portanto, as reações são quase imediatas. As reações que o carro tem. Depois... Participamos outra vez em Coimbra, em 2005, desta vez na faculdade na Universidade de Coimbra, e nessa altura ficamos em segundo lugar, acho. Pronto, este era o Atlas Car, neste caso 2005, Atlas Car 2005. Estão a ver aqui, conseguem já ver parte do processamento que ele fazia, aquela mancha branca era onde ele achava que estava a pista, e depois a prova não era só de condução, tinha também que resolver problemas como passar num túnel, entre outras coisas. Mais, eu tenho tantos vídeos que quero passar por eles todos. Em 2006 foi a primeira vez que o projeto Atlas ganhou, e tem aqui um vídeo muito interessante, eu não sei se vocês já viram este vídeo, mas eu acho este vídeo delicioso. Ao fim e ao cabo este vídeo mostra a inteligência que o robô tinha na altura. Portanto, o contexto era, nós estávamos, normalmente quando vinham estes festivais nacionais são um fim de semana seguido, e nós dormimos 5, 6 horas o fim de semana todo, portanto 1 hora por dia ou 2. E este era para ir no segundo, terceiro dia, e estávamos com um algoritmo que, normalmente quando uma pessoa faz algoritmos, eles falham sempre, mais tarde ou mais cedo, é só mudar um bocadinho os parâmetros, eles falham. E aqui este algoritmo estava a funcionar bem demais. Portanto, a ideia era o carro conseguir desviar-se dos obstáculos e continuar a navegar na pista. E nós começamos a ficar um bocado irritados porque, quer dizer, isto era para as 5 da manhã e o carro sempre a funcionar, o que era milagre, não é? O normal era não estar a funcionar. Eu estou a ser sincero convosco. Isto é um vídeo único, por isso é que eu gosto tanto dele. Normalmente isto funciona tudo muito bem e o caixote está ali. Alguém dá um toquezinho e o caixote, opa, não faças isso. Portanto, este carro também tinha esta particularidade de ser muito grande para a pista e tinha que fazer marcha atrás para manobrar. Mas aqui nós decidimos chateá-lo mesmo a sério. Ok, vais continuar a passar. Isto tudo com visão. E em 2006. Eu acho que o carro estava tão bêbado de sono quanto nós, neste caso, por isso é que estava a acertar estas coisas todas. Então agora, pergunta para o exame, o que é que ele vai fazer? Voltar para trás? Vocês não têm... Muito melhor. Anda por aí fora. Aí foi ele. Hello, good morning. Okay, so we switch to English. Gino is already here? No. So we switch to English. Sorry, I forgot to start in English. Okay, so in this year, 2006, we were the champions for the first time. So this is an example of the car doing the first round. There are 3 rounds. The first is just navigating around this race. Here, the idea is that you go as fast as possible. I like the sound of the car. So it goes fairly fast already. And here we were the champions. So up to this point, the code was mainly made by me with a few help of our professor, Professor Vitor Santos, and some of the other colleagues, but the other colleagues were more devoted to the hardware and the electrical component. The code was mostly made by me, and it was fairly complex. I will show you the code in a moment. And it started getting too complex, so it was almost impossible to maintain and develop this code. The reason for that was that it was a single program doing all of this. So this is 2007, the preparations for 2007. That's the laboratory, robotics laboratory upstairs. So here you can see the vision system, how it operates, the vision system at that time. So the green blob is where the car thinks the road is, and the blue blob is where the car thinks the area delimited by the construction site pins is. So it's switching modes. Now it's running in construction site mode. Now it's driving in the road. Okay. So anyone can tell me what this is? All of these timers. So you see here lots of timers, lots of state information, the angle of speed. Do you know how this was done? All in OpenCV with CV put text and CV lines. So you would already be able to do this if you wanted, okay? So it's nothing special. You already know how this can be done. So this is just a lot of CV text. Okay. Okay. I have to explain this one because I'm trying to hunt the car. What happened is that the car saw this, saw the green traffic light far away. And because it saw it, it stopped looking. So it saw, okay, I have a green light, so I just have to move forward. So when I change, okay, so you see here the car over there, before it reaches the cross, it says, oh, I'm seeing the distant green arrow up. So I'm not going to look anymore, and I'm just moving forward. But at that point, I pressed the cross, and I thought it would stop, but it didn't. So that's why. Okay, next. So in 2007, we were able to win again the competition. So this is the competition in 2007. So here you can see another version, the second round, I think, or the third, I'm not sure. So this is the most difficult round because you have to deal with obstacles on the road, with tunnels. So the problem with the tunnels is that your light changes. Typically, you have a threshold. For example, now for color segmentation, you inserted some thresholds in your color segmentation. If you go into a tunnel, the light is completely different and all your thresholds go away. They don't work anymore. So that's the difficulty of the tunnel. So we were able to win these 2 years and doing very good performance, but still the car was too large. So we had to maneuver to come back, and all the other competitors were much smaller, about half of this size. So we decided in 2008 to try a different alternative, which is to build a new vehicle from scratch. Okay, so this is an example of everything we did. So you can see the amount of parts, mechanical parts, electrical parts, And then on top of that, the artificial intelligence, the AI, right? And the computer vision. So we built what we call Atlas MV. So the Atlas project is the project about autonomous driving here, and that would be the Atlas MV. So the Atlas MV in 2008 was still under development. It participated but got third place, but the other Atlas won again the competition. And more or less at the same time, this is out of place, this is in 2011, more or less at the same time, we started developing a real full-scale vehicle, transporting what we knew about autonomous driving and handling with sensors and so on and so forth to a real car, okay? So this is the first autonomous vehicle in Portugal, developed in Portugal. It didn't drive all by itself, but it was able to do autonomous maneuvers, such as following a person, or, for example, here we are driving it with a remote command, teleoperated. This is 2011. So we had to instrument the acceleration, the thrust, the throttle, the steering, the brakes, and so on and so forth, okay? So you can see nobody's there, unless someone is driving in the trunk, right? My colleague around here, you will see him, he has it's an Xbox. Okay. Okay, I just started. So, this is another example of this Atlas car. So we did a demonstration where the car would follow a person that would be placed. I mean, suppose that someone will go in front of the vehicle would start following that person. So here it's being remotely operated, and it has a lot of sensors. You can see several cameras on board. These are the cameras, 3D LiDAR, well, 2D LiDAR, which is rotating, and several other LiDAR. This is more or less what the car used to solve. And well, if you want, you can search online for this kind of videos. In 2011, well, actually in 2009, we already started figuring out that the solution for the code was not going to work well, because we had a gigantic code which we couldn't expand anymore. It was impossible. I would change one file of the 30 or 35 files, and it would have influence on many other functionalities, typically breaking those functionalities. So we had to come up with a way to program the system without having to do such a huge amount of code. And the solution for that at that time was something called, well, that's the library that we use, but the solution, again, the idea of doing programs for robots is that doing programs for robots is very complex. So this is a hard task, a complex task. And how can you solve this? Because the task is going to be difficult. So the solution for handling this complex task is not to do complex programs, is to try to do simple programs. However, if you want to do simple programs, you have to do a whole bunch of them and have them communicate with each other. Okay? And that's where we started using at first Karman ICP, which was a precursor to ROS, which was a library which would allow a Linux system to have several processes which would communicate between themselves, between each other. And using this kind of approach, we would be able to do, for example, a single code for doing the drivers of the cameras, which were responsible for speaking to the cameras and extracting the image, and then sending the image to other nodes, which would pick up this image and try to process the image and try to figure out where the road is, for example. Then we would have some other nodes or processes which would do something else, such as, for example, communicating with a vehicle and trying to establish a steering angle, something like this. Okay, so the idea is to divide to conquer. That's the old motto, and that's what we use: divide to conquer. And actually, this idea of dividing complex tasks into several modules, which are much simpler, and have these processes communicating between themselves, is not new. And that's the idea under which, the basic idea under which ROS appeared. So ROS is meant to be used as a platform for providing tools which have already been developed that will be able to solve many parts of your problem. And then you just have to do the new part. Okay, so this is the Atlas car being remotely operated. And okay, so by 2011, we had won 6 times. Since 2006, we won all these autonomous driving competitions. Then we started working on real vehicles. And well, I can show you this one. Parking. This I call it horror parking. This is not parking. This is parking for scaring people, because we had problems with the controllers. If you can listen. We had problems with controlling the throttle. No, it's not in this video. There is another video where it goes, not here. Okay, so idea. Okay, no, yes. Then I started working on other systems, but ROS was on with full throttle. Then I can show you only one more project that I went to work on after ROS. This is the PR2. This is a very nice robot which has 2 manipulator arms, rotating head, several sensors. It's about the size of a person. And this European project I worked on had 7 or 6 institutions: Germany, England, Sweden, etc. And they were all working on the same software project for controlling this robot. And so they all collaborated using ROS. So that's the only way possible that we could think of to have so many people, so many researchers cooperating between themselves. Okay. Okay, enough with the videos. So, as I told you, if you want to program robots, you should not do complex programming. So, complex programming is for the informatics people. They love complex programming, but their problems are not so difficult. They have to put one button there or increase the size of the button, this kind of stuff. Of course, it's more complicated than that. But here we are focused on the scientific problem, not really on the programming issue. So if we can simplify the coding, the better. So what we have to do is to figure out a way to dismantle all these functionalities into simple programs. So we have to find a way to communicate between processes, okay? Well, a process is the execution of a code, and then you have to have these executions communicating between themselves. There are several ways in which you can do this. The most interesting way nowadays is the TCP/IP communication using sockets. This is interesting because it uses the wireless, either the wireless or the Ethernet communication. And as such, it can be the communication between two processes in the same computer, or one here and another in China, something like this, okay? So that's not a problem for this kind of communication. So the first exercise here is what I call a standalone TCP/IP communication, which is basically how we would go about producing 2 nodes communicating between themselves if we didn't have ROS. So how could we do it without ROS? And I want you to get this feeling to see how much ROS helps. So I will do this exercise. Number 1, let me go here to part 8. Part 8. Okay, exercise 1. What time is it? Yeah, I have time. I have to create 2 files, the server.py and the copy-paste, oops, no, copy-paste, the client.py. So we have two nodes. One will be the server and the other the client. First, I will copy-paste the code and then we will discuss. So copy the server code, paste, and now copy the client code and paste, right? So what's happening here? On the left-hand side, we have the server. On the right-hand side, we have the client. The server is a node which, when on startup, will initialize everything it needs to and then wait. So the server is passive. It's just waiting for someone to contact him and do something. In this case, the do something will be sending a message. So in this server client paradigm, the client is the active one and the server is passive. So the service is just waiting and the client will interact with the server and in this case send a message. So let's just take a look at the code of the server. So we start by importing some socket library. Then we are going to do the initializations of the socket library. So first we create a socket variable, which we call sock, and then we get the host name and then the fully qualified host name. And then we get the IP address because this is a TCP/IP communication. I don't know if you know enough about TCP/IP, but for a TCP/IP communication, you need an IP address to describe where the machine is or which machine we are talking about, and then a TCP port, which is here. So here we are defining the TCP port, okay? So an IP address, which is going to be 127.0.0.1, the local address, and then a TCP/IP port. Then we are going to bind this internet address, and we are going to start listening, okay? This listen is the part about being passive. So now the server is just waiting. Then in an infinite cycle, the server is waiting for someone to connect. If there is a connection, the server will accept the connection. If there is no connection, this try will not work, and then we will go into the next iteration of the while. Okay. So the server is just waiting until a message arrives. When such a message arrives, we enter this portion of the code inside the try, and now we are just this is just for connecting to a client. So when a connection is done, we are inside this while, and when we are inside this while, we are going to be continuously, that's why we have a while, receiving data and printing it when we receive it, okay? So we just receive data with line 32, and then if we have something in the data variable, we print it, that's it, okay? So this is the server side. On the client side, we import the same library, we do a similar configuration, okay? So instead of binding here, we do the connect because we want to connect to the server. And then here, that's the important part, we define a message, which in this case, I define that the message should be 30 robotics, 31, 14, automation 18. That's just what I remembered at the time. So you can see how organized my head is. So I can, my goal is to send each of these elements in the list. So 30, then wait 2 seconds, then robotics, then wait 2 seconds, then 31, and so on and so forth. Okay, that's the goal. And in this side, in the client side, the client will receive each of these messages and should print them. Therefore, we will know that the communication was established correctly if we see the same prints on the left-hand side that we see on the right-hand side. No questions, right? That's easy. So first, let me pick up the path. CD, paste. Diga, qual é a sua dúvida? Não tem nada, não? I created these files without being executable, so I have to chmod them. Now they are executable. Now I will split the screen. On the left-hand side, we will have the server. So clear end./server. And on the right-hand side, we will have the client. Right? So look, one argument. Wait. I did something yesterday that didn't work. Wait, just a moment. I have to check my solution because I did something that, well, I can actually, I think I know it by heart. So data or message formatted equals message str. I think I can do it like this. And then now I send message formatted. Let me see if this works. I was trying to simplify the code yesterday night and didn't work. Okay, now yes. So you can see I'm sending message 30. On the left-hand side, we receive 30. Then robotics, then 31, then 14, then automation, and then something else, okay? And then the client exits. So the client is already not working anymore, while the server is still working and waiting for another connection. So I could, in fact, launch another client, which would send, again, the same message, okay? So you can see here how we can get a communication between the two processes. Now, what's the problem with this communication? It's what I say here, okay? So we have, in my view, 3 problems or 4 problems. The first is the complexity. If you take a look at this code from the left-hand side and the right-hand side, it's actually very verbose. It has a lot of stuff to do with communication. So this is what we are really passing from one side to the other is nothing, no big deal. It's just this message here. Yet our code already has a lot of stuff to handle the passing of messages. So the code footprint, which is related to the communication between nodes, is very high and very large. And this is a problem because what we wanted in the first place, we have to keep in mind our initial goal, was to divide to conquer. So we wanted to divide a complex program into simple, into several simpler programs. Now, if these simpler programs are going to become harder because they have to do with handle communications in this way, so the programs stop being simple, they are complicated again because they are handling a lot of stuff which has to do with communication. And that would defeat the initial goal, the initial purpose, okay? So you cannot, if you want to divide to conquer, when you divide, you cannot have very complex divided nodes. You have to have them simple. So that's one problem. Another, for example, is that what I've showed you here is just one of the several communication paradigms. You can have a server client, but you can have other paradigms as we will study in ROT. And this specific code only handles one of them. So if you wanted to do another, you would have yet more verbose, yet more code footprint. Then also about the communication topology. In this case, what's happening is that this client is communicating with this server. There are some applications, however, where we want a message to be broadcasted. And a broadcast is when you send a message as the client is sending, not to a single process, but to many, okay? It's like when you go up into the square, you pick up a megaphone and you start speaking for everyone. In this case, this architecture does not allow this functionality. You can only speak one person, one node to the other. That's another limitation. And then this is the most important part, in my opinion, that has to do with the serialization. Now, what's happening here? When we send one message from the client to the server, we will send it in a serialized communication channel. What does it mean? It means that our message will be flattened. What does it mean to be flattened? It means that it has to be as if it is sent on a train. All the bytes from all the information that you want to send have to be put together one after the other in sequence. And then this sequence of bytes is sent to the other side. That's sent in a serial line. And after it gets to the other side, it has to be translated back into its original shape. That's what I mean by serialization. It's also called marshalling. So serialization is a process by which you pick up information, for example, that is in a list or a dictionary or in a class, and you put it in a byte array, a sequence of bytes, in order to be able to send it. So what we do, when we do send all, this is already a byte array. And then the byte array goes to the other side, and when it gets there, we have to do the reverse process, which is called deserialization or unmarshalling. And this reverse process is the process of picking up the train of bytes and understanding what each byte means and reconstructing the original data structure. Okay, makes sense? So Ross handles this very elegantly, but first again, I will show you how we could go about doing this on our own. That's exercise 2. So I will create here a copy of EX1 called EX2. And I have to write clear all, and now we go to EX2. Okay, come on. Okay, so now the client goes to the left-hand side, the server is on the right-hand side, and exercise 2 says the following. Okay, now suppose we have a complex data structure, which is called a dog, class dog. So you learned about classes already. And in this case, we would have a class which would describe a dog. And all we have here is a constructor, the init, in which we will define the name, the color, and the age of the dog by creating these properties. So here I'm creating 3 properties, self.name, self.color, self.age. And then we would create also an empty list, which are the brothers of the dog. Then we have a method in this class, which is the add brother method, where we could add a new dog by appending the dog's name to the list of brothers, and so on and so forth. Okay, so this is just a data structure. Typically, it's much more complex than this, but for now, I'm just using this as an example. And I'm going to create a file here, new file, doglib.py, where I'm going to put this code. Okay, so here we know what a dog is because we have this doglib. So now, what do we want to do? We want to create an instance of a dog from the client side. So all this part about the connection, all this part that I have here in blue is going to remain the same. So I'm not going to touch this part. Now, the part that I want to change is this part where I want first define a dog to be sent, right? So how can I define a dog to be sent? Well, first I have to import my newly created library. Then I have to create a new variable dog, which is an instance of class dog, okay? And if you take a look at the constructor, which I can put here on the left-hand side, you know that you have to provide a name, a color, and an age. So who has a dog here? Okay, name. Dalila, okay. Dalila, Sansão e Dalila, very well. And the color? Brown. And how old? How much? 5, all right. So here we have Henrique's dog. Dalila, what's the problem with my dog? It doesn't work. Class dog, what's wrong? Add dog, oh, it didn't like the import. Okay, let's see if this works. Now we can actually print Henrique's dog like this, dog. Why does it work, this print dog? Because I defined this special function in which when I print the dog, it will print all 4 properties, the name, the age, the color, and the list of brothers with special colors, just so it's easy to see the prints, okay? Let's see if this works. Yeah, not here, sorry. So of course, now we have to go into the other folder. All right, oops, sorry. Now, yes. Now we launched the server. Here it is, so it's just waiting. And now here we launch the client. So the client is still going to send the same message because I didn't change that code, but it created a dog called Delilah, age, color, brown, blah, 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 blah. We can actually be more, we can actually expand this class to put here the owner. And we will put here self.owner equals owner, right? So here, in this case, we would put Henrique. Henrique. Okay, I need to change the print as well, right? So let me put here owner. For red, let's put the owner's name in blue, and this will be self-owner. Oh, yes, that is Henrique. Okay, so now the question. Okay, we have a data structure with lots of properties. We want to send these properties from the right to the left. And how can we do this? Well, we can, as we did before in these messages, we can just send each of the properties to the other side. But this will be scattered information. The other side will not know how to interpret. So instead of sending messages which do not make any sense, our goal now is to send only one message with all the information together. Because I don't want to send the dog information in 10 seconds because I'm waiting 2 seconds every time I'm going to send a new information. No, I want to send it very fast in a single train of bytes, in a byte array. So I have to somehow organize this information. Well, let's say how. So you, for example, do you prefer the property name or age? Name. So for you, name is better, more important. So let me just do something like this. Let's comment this for now. So if you prefer name, great. So let's say message, our message to send starts with the dog.name. Okay, so someone else. Do you prefer commas or semicolons? Go ahead. So message, comma, you prefer commas. Okay. Now, who else? Age or caller or owner? Go ahead, someone tell me. Owner. Okay. And now I can put the age. STR. Sorry, I have to split with commas the owner and the age. And finally, I have to, again, do a split here. And now I have to add the brothers. So how can I add the brothers? No, I'm missing the color. Wait, first the color. And now, yes, now I need to put the brothers. Can anyone tell me how I can add the brothers? No idea. So I can just iterate the list of brothers and append to the message text the name of the brother every time. So for brother in dog.brothers, you are going to, whenever we have a new brother, we have to append to the message the comma with the brother's name. Brother. Makes sense, no? So this part is what we call serialization or marshalling. All this. Now we have to send the message. Right? So how can we send a message? Like we did before. So we are going to send, we can put a loop just for sending over and over the same message, while true. So we're just sending over and over the same message every 2 seconds. And we are going to say, I'm going to send message. I'm going to format it. In fact, this is not necessary anymore because I made sure that everything here in this message, because message is already a string, so I don't have to convert it back to string. I can just delete that part. Before I had to do this because I had this 31 and 14. These were integers that I needed to make sure were formatted as strings. In this case, no, I can just send the message directly. And that's it. So let's try. So again, I'm doing this and it says, oh, I'm sending the message, the little Henrique 5 brown. The little Henrique 5 brown. From the server side, it's already receiving what we are sending, the little Henrique 5 brown. Makes sense. Now, let's add some brothers here because we forgot to add brothers. So here, let's say, Henrique, how many brothers your dog has? Okay. Add brother. Name of the first one. X. And the second? You think? Okay, you're talking about real brothers which do not live with her. Okay. Yeah. Okay. That is Rex and Zeus, okay? If yours is the Lila and the other one is Zeus, I think you got the worst dog because the other is like a god. Okay. And so we are sending the information. And now what are we missing? So from the other side, from the server side, we don't just want to pick up this byte array, this train of data, and just print it. We want to use it. So for example, suppose that I want to add a new brother to Henrique's dog on the server side. So I need to receive this information and I need to create a new instance of a class which contains this information in the right place. Okay, so we need to do the decoding of the serialized byte array. So now we have to handle this side of the things. Okay, so where can we work on the deserialization? Well, it's obviously after we receive data. So when we are printing here, we have to deserialize or unmarshal. Unmarshal. I think that's well spelled. So how can we do this? Well, we do this by knowing exactly in which position each component of the message is stored. So we have to split the message or the data into several elements of an array, and then we will know by the position of each element to which property of the doc it belongs to. So that's why we used here separators used as commas. Okay, so we used commas in order to be able to separate the information, and in the end be able to reconstruct the data. So we are going to do something like this: data dot split. That's a Python function which is able to split a string into a array, into a list of strings by splitting every time there is a comma or some other pattern. That's whatever you want. So for example, now I'm going to say messages equals data split, and we are going to print the messages. So again, I will launch the server. I will here launch the client. And you can see here that it received data Henrique Brown X0. Let me stop this guy. And then it was able to split into a list. How do I know it's a list? Because it starts with brackets. And then how do I know the elements are well separated? Because I see the Lila, then comma, that means a new element, Henrique, that's the owner, then comma, the age, and blah, blah, blah. Okay, makes sense. Now, all I have to do now in order to do this translation is to say something like this. Let's create a new dog. Dog, okay, so I have to import as I did here. Well, it will import automatically. I don't have to worry about it. Is it importing already? It's not complaining. I think I have an import dog here somewhere. No. Well, it will complain eventually. So here I have to put the name. Anyone tell me how I can retrieve the name? Take a look at this. How can I get the name of the dog? The first element of the list. So messages 0. Let me be explicit, it's better. Name equals da, 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 da. Then what's the second? Then we put the color. So color equals, where is the color in the list? 0, 1, 2, 3. So it's the index 3. So the color is the messages index 3. Then then we are putting the age equals. So where is the age here? Sorry, here. 0, 1, 2. So 5 is on position 2. So messages position 2. And we are missing the owner, which is in messages position 1, right? So the owner here is in position 1. So that's it. We have our dog created. Well, not our dog, but almost all of the dog. Let's print it for now. So again, we run the server. PSR linha 9. Yeah. I thought it was strange. Okay, so now we can import this. Now, yes. No. Why doesn't it work like it did here? So I imported dog-lib and it was not a problem. Let's see if it works. Okay. Yeah, it works. So the server is running. And now on the client side, we are going to send information and it says name dog is not defined. Import dog-lib. It wants to do dog-lib.log. Okay. Dog-lib.log. Okay, another attempt. Now we have the server and the client will send information. So you can see here that we are, I'm going to stop the client, that in the server side we already received, we were able to reconstruct a data structure where the name is Delilah, the age is 5, the color is brown, the owner is Enrique, and we still don't have the brothers. How can we add the brothers? I will copy paste this message that we received up there, so it's easier for you to think what you should do. So this is the message. This is the data we received. Oops, sorry. This is the data. And the question is how to add or reconstruct the brothers. And I have 12 minutes, so I can wait for your answer. Come on, you can try, and if it doesn't work, it's not a shame. You want to create another array with, okay. Well, like we did here. We don't need an array. I agree, we don't need. So what else do we need? An array doesn't exist in Python. When we say an array, it's a list. I mean, we don't need. We have it, but it's internal from the class. It's the self brothers, and we use the method add brother to append it to the list, right? So that's why we don't need, because it already exists in the class. Go ahead, Enrique, or someone else if you want. Somehow I always convince myself that silence is the signal, the sign. Silence is the sign of understanding, and it's not. It's the opposite. But when you are very silent, I think that you are understanding. It's the opposite, because it's not so hard. I would say, for example, we were able to pick up the name of the dog, the name of the owner, and blah blah blah, all like this. So if I ask you something else, how to pick up the name of the first brother. First brother equals, who can tell me? This you have to tell me. Right after. What should I write? What do I write? You can see it's messages, the name of the. It's messages and then the element. So Dalila, Enrique, Dalila, so 0, Dalila, Enrique 1, 5, 2, Brown 3, Rex 4. Second brother. Fine. Okay. So we could now just do something like this. Dog dot add brother. First brother. Second brother. Right? Makes sense? Let's see if it works, and then you tell me if you agree. So first I create the server, and here I'm going to create the client. And you can see now that the print is okay. Now we have brothers Rex and Zeus. It worked. Is that it? Everyone agrees with this code? There are nothing itchy there. Okay. And also, if you have less brothers, it will be a problem, right? For example. Right. How can we do that? That's a good start for, yeah. For index in range. Now, where do we want to start? Which index? Fourth. Yeah, right. That's the first brother. It's a fourth. Until if you iterate between, if it doesn't exist, we will handle it. Don't worry. So between 4 and what? And how many? And how can I get how many there are? The length of the message that I received. Right? So, in fact, your question, which was very intelligent, is already handled, because this range from 4 to the length of messages. If I do not have brothers, the length of my message will be 4. And if you say between range 4 and 4, it doesn't iterate. So going from 4 to 4 doesn't do anything inside the for loop. So this will, in fact, go through each brother. And for each brother that you go through, you just add this brother to the list of messages. Index, that's the name of your if brother, or index brother. Okay, so this is, now we don't need this. So this is just adding the brothers, as many as there are. So let's see if it works. So again, new server, a client in which we send 2 brothers hexens use, it's working. Now we are going to stop this client and change the code of the client while still the server is running. And we are going to add many, well, I told you Zeus was like a god, so it's going to reproduce like a god or something like this. Okay, so we have many brothers now, and it worked no problem. Okay, so serialization is about doing this translation in order to send the information and then translating back to the original format when you receive it. And it's not as easy as you see here. It's more complicated because there are some issues that I didn't mention just because, well, I can mention, but we will not address them. For example, if I have 2 lists, if I have the list of brothers and the list of sisters, then it will not be as easy because I have to put 2 lists and I don't know how long one list is and how long the other is. So I never know until when I have to read the name of brothers and from which point onward I have to read the list of sisters. It's possible to handle, but it gets much more complicated than this. This is just a simple example so that you know, so that you start being ROS fans and say, oh, ROS is really helping me. Okay. How? Go ahead.
Yeah, it's just for elements in the rest of the list using
yeah, makes sense. I like it. Yeah, even better. So for brother in, and now what we want is to iterate the messages. But if we iterate the messages, we are going to iterate the name, the age, blah, 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 blah. Now, we don't want to iterate that. What we really want to is to iterate from the 4th onward. So we can just say, create a new list that goes from the 4th until the end. That's it, right? And here we just put our brother. Yeah, I like this one better. It's more Pythonic. Okay, let's see if it works though. Okay, here it is. Okay. So everyone understood this or not really? Yeah. Okay. I was saying, where was I? Okay, so ROS will help you a lot doing this serialization and so on. You can do it using other tools. For example, I did something with 0MQ, which is the way you can send socket information from one place to the other. And then in order to serialize, you can use Google protocol buffers. So there are other tools, but ROS is one that already implements this and it works very well. It's simple to use. And on top of that, ROS does a lot of more stuff that we will learn what this is about. So ROS is not just about passing information between nodes. It's a lot more, but this is one of the critical components, okay? So after the evaluation in the practical classes, we will continue and do the same thing in ROS, okay? So we are going to start working with ROS from now on. Okay, so let's meet in the practical classes. Thanks.